Okay guys, so the first thing we should do here is probably turn this into an augmented matrix. And then remember what our end goal is. Our goal is to take this augmented matrix and turn it into an identity matrix, where we have ones across the diagonal and all other entries on the left-hand side are 0. And to achieve this, we got to get rid of all the numbers underneath 1. So let's first get rid of 3. Since we can't multiply a row by 0, we're going to have to multiply row 1 by -3 and then add it to row 2 in order to eliminate it. Remember how this notation works. The first R subscript 2 means that we're only changing row 2. But in order to do that, we must first multiply row 1 by -3 and then add it to row 2. Remember what the arrow means. It means we're only changing row 2. So let's bring back R1 to how it was before we multiplied it by -3. So we've successfully created a 0 underneath our 1. However, we still have this 5 in that column. So what we should do is follow the same procedure and get rid of that 5. Let's multiply row 1 by -5 and add it to row 3. This will result in a 0 occurring in the bottom of the column. Now that our first column looks like the first column of the identity matrix, let's move on to the second column. Our first goal is to get a 1 in that middle entry. So let's take row 2 and divide it by 10. At this point, we have to eliminate the numbers above and below 1. So let's start with 17. To change row 3, I'm going to start by multiplying row 2 by -17. Then, I'm going to add it to row 3. This will result in a 0 occurring under the 1. And while we're at it, let's go ahead and make that last diagonal entry a 1. Let's divide row 3 by 4. Let's just pause for a second and see what we have. This form right here is called row echelon form. It's where each leading entry of a row is in a column to the right of the leading entry of the row above it. Also, all entries of the column below a leading entry are 0. The interesting thing about row echelon form is that we can use substitution at this point to solve for x, y, and z. But what we're going to do is reduce this down to an identity matrix into a form called reduced row echelon, where all leading coefficients are 1 and all other entries are 0. Alright, let's get back on task. In order to get to reduced row echelon form, the next thing we should probably do is get rid of this -1 in the third column. This one will be easy. All we have to do is add row 3 to row 2. We're almost there. All we have to do now is get rid of -2 and 3. Let's start by getting rid of 3. If we multiply the third row by -3 and then add it to the first row, it'll end up canceling out that 3. We're going to follow the same procedure to getting rid of that -2. We're going to multiply the second row by 2 and then add it to the first row. So there we go. We create an identity matrix on the left-hand side, and we've reduced this augmented matrix into reduced row echelon form. So what does this mean for us? Well, the first row says that x equals 1, the second row says that y equals -2, and the third row says that z equals 3. So there's our answer.